Cool. I'm excited. So, intro to password cracking. How many of you guys have done password cracking before? 1, 2. Like a lot or a little?
As I need to.
Teeny.
Teeny. Good. Because this is legit. We're going to start from I've never done this before. What is password cracking? Intro to password cracking. So, first off, password cracking. Like, what do you guys think? Why do we do password cracking? What's the point of it?
Free internet. I'm just kidding.
Free internet, yes. Okay, so I assume what you mean by that is hacking your neighbor's Wi-Fi password. I've never done my neighbor's. I've always done my own little APs, but yes, it's possible.
Sometimes when you need to fix a system or something, you might need a specific type of password, or some system might be bricked and you need to get certain information. So any kind of passwords that you can grab.
Right. Super useful. Yeah. I have seen so many uses for password cracking, though recently most of them have been in people's red team exercises. So you pwn a box. Once you're on a box, what do? You grab the creds and you try to pivot from there. That's the most common one. So today I'm going to we're going to work a scenario of pwning a box and grabbing some hashes and then working on cracking them. So I've got a cute little WordPress site that I set up for you. Let's see. It's a turnkey Linux WordPress. So I don't know if any of you've done turnkey before. It's just cute little
Super secure out of the gate.
yeah, super secure out of the gate Linux distros. So this one here is a default install of WordPress. Like, it took me 20 seconds to install it. I followed its little installer and then I did nothing since then. Haven't updated anything, haven't done any of that. So if you want, I mean today we're not going to go through it, but if you want to, you can pwn this box because it's running WordPress, if I remember right, 9.7.4, and we're like at 9.9, 6.7.4, and I think we're at 6.9 something. So that's fun. So, do any of you guys know how WordPress stores its passwords? Hashes. What?
And the WP users table.
Okay. Does anybody know anything else? Perfect. Good. So you shouldn't, because it's a beginner class. So he said that they store them in hashes. What's a hash? So that's a question that I want to make sure I answer today, because it's kind of important. And without that answer, well, you'll be stuck. So I have a nice little picture here that kind of explains it. But I want to talk to you and explain it with words. So a hash is called a one-way function. So it's a cryptographic function, and I'm not going to get into math because math sucks, that you take an input and then you put it through the math and it comes out with a pseudo-random bit of gibberish. Now I say pseudo because it's not really random. The point is you're taking the input, you do the math, and it comes out with the exact same output every single time. It seems random to us, but mathematically it's not. And the important part is that it's a one-way hash. So I can easily go from the word fox to this stuff here, but I can't go from this stuff here, or known as the hash, backwards. It's impossible. That's the idea. So go ahead.
Without going into the math, what hashing function is it using? Like SHA-256, SHA-1?
The picture?
Yeah.
I don't know what the picture's
MD5.
using.
Okay.
I have no idea what the picture's using. If you can tell, if you're looking at it, you can notice that it's all looking like hex bits, because what it is you're taking this input and literally just turning it into binary ones and zeros, and just so that we can easily see it, it shows it as hex. This picture and this hash, I don't know what it is. I haven't checked, but I assume that it's an MD5 hash. So it is a little long for an MD5, so maybe it's something else. Maybe it's a SHA-1. The cool part is that every single time you do it, change even a little bit, it should change it drastically. So let me show you how to do a quick hash in the terminal. So I'm going to do my handle, bashninja, and I'm going to hash that as MD5. because that's what he mentioned. So that's what my handle looks like. Can you see that? Is that too small? So that's what my handle looks like hashed. Now if I were to change this A to the next letter to B, the hash that comes out is significantly different. Strange that we had the same first letter, but I think that's just luck. So you just change even a little bit, it should change the hash completely, and that's the idea, is that it's impossible to go from this hash to the password or the thing that we're storing. Does anyone have any questions? Does that make sense? Sweet, awesome. So, WordPress is something that we want to look at. So I'm going to pull up this cool little thing. So, believe it or not, Turnkey has a fancy little protocol that lets me view the database without really doing too much. So you guys can hit this if you want to. We'll see if we can take a look at the way WordPress stores its hashes. Okay. Nope.
What port was that?
12321.
It's 12321. So what I did is I just logged in with the root user on this little VM. I'm not going to give you the password yet. I will, but we'll turn the recording off first. But I'm going to come in and look at software packages. So I can come up here to the MySQL database server, and we can look at the databases that this MySQL server has. I'm going to pull up the WordPress. So you can Google where WordPress stores its passwords, but he already told us it's in the WP users section. And so if I pull it up, we can see that we've got a user called admin, and we've got another user called Dumby, and he's not here, and then we've got these passwords. Now these aren't these users' actual passwords, these are hashes. So somebody's done something similar where they've taken, say password 1, hashed it, and then put that in here. Something I wanted to teach real quick is these dollar signs that you'll see in them. These are usually not part of the hash. These are indicators of sections in between the passwords. So this P here is kind of indicating what type of a hash it is. So sometimes you'll also see something similar to this, where you'll see another dollar sign here, and this ends up being what's called a salt. So let me actually SSH into this box, and we can look at another place that password hashes can be stored. If I type my password right. Okay, so does anyone know where passwords are stored on a Linux box? Okay, so we said Etsy password, but that's a lie. It lies in its name. It's Etsy Shadow. So you can look here. Most of these don't have passwords, but the root user does. So you can see here, here's the number 6, indicating the hash type. Here is our salt, and I'll explain what a salt is in a second. And then here's the hash that comes out. So a salt, what it does is it does something fun. So say your password is password123. Horrible password, please don't use that. If I were to hash that, oh, that's too small. Hang on. Okay. So every time I run it, it should come out the same. Now, to make it hard for people to crack, what they like to do is they like to take the salt, and what they'll do is they'll randomly generate some gibberish and put it at the beginning of the password and then run it so that it's different. So in this instance, they take this phrase, run it in front of the password like that, and then hash it. And then somebody else's, even though they have the same password, they would get a completely random salt. So we'll do, and even though they have the same password, it's a different hash that ends up getting stored. They make that so it's really hard for people to use things called rainbow tables. And rainbow tables are just somebody goes through and generates every single hash for every single password that's possible. And since we started doing salts, rainbow tables have become significantly less common because they're not useful anymore. Any questions?
That salt is plain text, though, of what we're seeing is the actual salt.
Yeah, so what we're seeing is the actual salt. And the reason why is the program has to be able to add the plain text salt to the password that they give it. So they'll add the plain text salt, and then they'll add whatever the user ends up typing in to then get this. And if they don't have it in plain text, then there's no way to add those two together to get the last bit.
And this is because when rainbow tables, basically, they do all the pre-compute, the hashes of common passwords, and they cheat, but salts make it so you can't cheat anymore.
Exactly. So does that make sense? Does anyone have questions about that?
I do.
Okay.
So a salt, like, if your password is password 123,
Yep.
will the program itself implement a random salt in and of itself, and then your password is still password 123, or is it with the salt, then your password?
Usually the programs make up the salt.
Okay.
Okay. Some poorly designed salt per password. Some poorly designed websites will use the same salt for everybody on the server, but that makes it significantly easier to crack.
Right. Makes sense.
Yeah.
Thank you.
So the other cool part and the reason that we use salts is because if one user has password 123 or another password, we run through a whole database of passwords that we want to try and see if it's the right one. Then when we get to the second user, we have to do it all over again.
Also, what's the standard length of a salt? Is it that 4 digits that we see here, or does it vary between different companies, or do they normally like to make
It
longer?
varies all the time.
Great.
It varies. I don't see a ton of benefit for salts that are bigger than 4 or 5 characters, because at that point, I mean, it's pretty random anyways. But I mean, I've seen as big as 6 or 8 characters for the salt.
Thank you.
Yeah. So anyways, let's get back to WordPress. So WordPress, we have these salts here. And so we want to crack them. So we want to get Dumby's password. So what we'll do, and if you don't know, Dumby's an 801 Labs member here, so that's why I'm picking on him. So what we'll do is we need to identify what kind of hash type this is. So I'm going to pull up my Kali box. See if I remember my password.
Sure.
Nope. I tried that first. Got it. Okay. Phew. We're going to use a Python package. It's pre-installed with Kali, but you could pip install it pretty easily. It's a tool that it's not perfect, but it's called Hash ID, and I like to use it because, well, it helps me identify the hash. Zoom in. Okay, Control plus. Oh, come on. There we go. So we've got Hash ID. And so what you'll do is you'll run it and then paste your hash in and see if it can figure it out. And I'll show you how it works. So what it does is it takes the hash, it'll see if it can figure it out this way through the identifier, but if it can't, it'll run through and just check the length and the type of characters that are used and so forth to kind of guess at what it is. So in this instance, Hash ID was able to correctly identify that it's for WordPress. Specifically, WordPress uses a program called library called PHP Pass, which other programs like Joomla and I believe Drupal as well, they all use this library to hash their passwords. So I'm going to show you see if it can figure out this password that we did over here. Okay, so unfortunately with this one, the way that it's formatted, it doesn't have a cute little identifier. It's not telling us, it's just random hex. And so it says, sucks to be you, but these are all the ones that are possible. So we kind of have to guess at it and try and see if we can figure it out. Now, does anyone have any suggestions how you try and figure it out? Like, think about it, like, what would you, let's say you have a password dump of maybe 1 million different passwords. They're all hashed using the same hash type, and they're of this hash type that looks like this. How would you go about trying to figure out what kind of hash type it is?
Would we know where that dump came from, whether it was a website or from some kind of user account?
So we would probably know, unless we're buying this on the darknet, like we'd probably know where it came from.
Great.
So that's a great way to figure it out. So a good instance would be, say you're doing a red team exercise and you pwn a box, go search through the code and see if you can find where it identifies what kind of hashing type it is. So for example, with WordPress, I went and dug through it, and let's see, actually, I pulled up, yeah, I went and dug through it and found, oh look, here's where they hash the password. What is this password hash section? Came in here, found in here, figured out, oh, it's using the PHP pass library, and you can even read the code itself and figure it out. So that's a perfect way. In fact, that's the recommended way, because then you know 100% what it is. And if you've, say, got in through, you know, vulnerabilities in a web page, hopefully you can put it on a PHP shell or something of the sort to figure it out. Okay, so let's say we weren't the ones to get the database. We were just given a dump with these kind of passwords.
You probably start making some assumptions, the most common of those available.
Exactly. So that's where I was going. So say we think, okay, they're probably, we've got probably some stupid people who are either creating fake accounts or whatever, and so they don't care about their passwords. They're just going to do dummy passwords. So what we'll do is we'll go through the whole dump, try each hash type with, say, the password or 1 2 3 4 5 6 7 8 9. Some idiot's got to do that, right? And usually what you'll do is you'll find something that matches one of these, that is on your database and matches the password. Those are the kind of methods that I've seen before. I'm sure professional password crackers have a bunch of better ways to do it, but that's a good way to figure it out. Okay, cool. So we've got a hash type, we've got a hash, now we need to crack it, and that's where the fun part comes. So I'm going to teach using a program called Hashcat. There's a few others like John the Ripper and so forth. But I like Hashcat because it's easy and it works and it's very common. Most people use Hashcat. And the way that Hashcat works is it'll use whatever device type you give it. By default, it'll use your GPU. So did everyone get Hashcat installed? Yeah? Okay, so what I want you to do is we're going to go ahead and we're going to try and crack a password. Now there's various methods that you can use, and this is where it gets complicated. We're going to stick to the simple methods right now, just because I could have a whole other class about other ones. But the methods that we've got are, we can do brute force attacks, which those are, say we're trying the password AAA, AAB, AAC, you know, and just going so forth, trying every single possible combination. The other fun ones that we've got is we can do word lists, so that's dictionary attacks, and we can do combinations, and we can do masking. So today I'm going to talk about brute force, because that's awesome. I'm going to talk about masking, and then we're going to talk a little bit about word lists. We're not going to do much on the combination or the hybrids that they've got available. Does anyone have any questions? No? Okay, so we're going to work with an actual database, and I want to play with it. So if you haven't heard of hashes.org, this is the coolest website ever. Basically, a community all gets together, it finds leaked passwords, and they all try to crack it. And then they post the passwords public for everyone to see. So, do any of you guys remember the LinkedIn password dump? So on here, they'll have Dropbox. They'll have LinkedIn right here. And they'll tell you the hash type if they've got it. Sometimes it's unknown when they're posted. And then you can look at what's found or what's left or all of the above. So what we'll do is we'll pick a smaller one. We'll pick something that's not too crazy. How about Planet Minecraft? So what we'll do is we'll download this hash database here. It's about 16 megabytes. And we'll take a look at it. So the way that they format theirs, so these are their found ones, is they'll show you the hash that they've got at the beginning, and then this is their plain text, how they've cracked it. So they like to list their cracks in hex if they need to. It looks like this whole one is all done. So we can take a look at, like, say, this password. Look at it in hex and figure out what they've got. So that password was planet.minecraft. That's a really lame password. That's so sad. Oh my gosh, why would you use the password Planet Minecraft? Okay, anyways, so what we'll want to do is we'll run through these, and this looks like a really cool database of passwords that we could use. Now, I'm not going to show you how to use them. That'll be our second class because pulling it from the hex to the plain text can be kind of a bugger. But these are good places to start practicing. Anyways, we were going back to cracking a password. Let's crack Dumby's password. So what I'll do is we've got this hash here, and I'll put it on pastebin because that's where all the good passwords go. Okay, so our paste is, so that's the URL you can hit to get to the password.
On the guest Wi-Fi, I haven't been able to get onto hashes.org, and I don't think I'm able to hit
I haven't either.
pastebin currently.
Yeah, I might have broken the
Stop breaking the network.
network. Hang on real quick. Is this gonna kill it if I blank my monitor for a second? Okay. Let me fix the guest Wi-Fi. So you can't, can you hit any website?
I can only hit the turnkey, but that's because it's an internal, and then anything external I can't hit.
Anything external you can't hit.
I can't hit Google. Google search, and go. And then it's right.
All right, try again.
Okay, I got Google. Hashes.org came up.
Perfect, okay. All right, let's plug this back in so you can see. Oh. Yeah, that'll do it. Okay, so what we're going to do is we're going to pull up this. Does everyone have the hash? Okay, so now that we've got the hash, I'll leave that down there so you can still see it. We're going to use Hashcat. So let me teach you how to use this tool. So Hashcat, it'll ask for a few things for you to use it. They've got their awesome examples here. In fact, this one is exactly the one we're going to use, slightly changed, because this one's set for the hash type -p or PHP pass. So we're going to do Hashcat. So -a is asking what kind of mode do you want to do. Okay, and so we can look at the modes that are available, and I'm going to try and refer to the documentation, the -h flag that they've got, so that when you do this yourself, it's pretty easy. So the first one is straight. The second one is, second one is combination, and the third one is brute force. So we're going to try brute force on this one. So we need to do -a for our attack type. I'm going to do 3 for brute force. We're going to do -m for the mode. Now, since we've identified the hash, we know what kind of hash type it is. We need to go through the list that they have. So I did -h to pull this up and see if we can figure out which one of our hash types matches in here. So specifically, we want to find PHP pass. So that's the mode we're looking for. You'll also see that if you look, here's WordPress, and it's the same number that it has on the left. They've just listed it because people ask too many times, where's WordPress? Yeah, so we're going to do -m, and it's going to be 400, so the one that matches. And then we need to give it our hash. So unfortunately, I'm going to have to change. Sandbox. Okay, so I'm going to create a file called with our hash inside of it. So usually the way that you'll create these files is you'll have a single hash per line. So if you'll have a different one, you'll put that here. In fact, let's see if we can get the admin password to this box. So we'll put that in there. And we'll try cracking both of those. So let me do that again. Hashcat -a3 -m400, A for the brute force, M for which hash type. And then, let me make sure I do this right. We want to give it our hash. Okay, so I did dummy.hash, that was the name of the file, and I just hit enter. And it starts working. So now what it does is it just goes. It kind of does it in the background. It takes a long time. And I can hit S for status, and I can watch where it's going. Oh, so I'm going to hit Q to quit, and it says that it's recovered 1, which is crazy because it shouldn't have recovered it. And then I remember that Hashcat has a cool thing called a pot file. So what that means is that ones that you've recovered before, it'll save them. So if I can do
Man, my GPU is getting hot. Hashcat told me it's slowing down.
So if I look at my pot file, it can see that I've got these 2 hashes that I've solved. So let me remove that so that my old solves aren't going to mess with what we're doing. So
everyone's computer starts getting pretty.
So yeah, so if you're running Hashcat, it's going to be plowing through your GPU or your CPU, if that's all it can get, as crazy as it can. And that's why I said bring your power block, because it'll eat your power. It's pretty fun.
Also, sometimes you get more performance when it's plugged in because you can get
Yep.
power.
Yeah, and a lot of laptops will limit your GPU power based on how much battery or if it's on battery. So this is going to sit here forever and just try things. So you can watch the progress as I go. I'm just tapping S a bunch of times. So with progress, you can see what it's testing. So it's testing 9A, 9Q. It's just going through the whole thing and trying everything it can to figure them all out. So unfortunately, the passwords that I've got now, it's in 3 letters. The passwords I've got are really long. So it's kind of cheap. So what we'll do is we'll generate with WordPress a smaller password and see if we can get a brute force with it. So let me look. So I'm going to log in with the password that I know. Maybe.
We might not be able to get in because we found it.
Okay. Wouldn't surprise me. And so I'm going to create a user with a smaller password so that you guys don't burn your machines. So who wants to, who wants to volunteer or tribute?
Pips.
Pips.
That's cool.
Okay, so let's give you, what do you want your password to be, Pips?
7.
How about the word 7? Is that all right?
E.
Okay. Thankfully, WordPress is nice, and it says you're using a weak password, so you have to check the box to confirm it. Let's give you admin privileges. P.S. This box is live. So now, Pips has admin privileges. So let's look at his his hash here that WordPress does. So here's Pips with his password 7. But we're going to pretend we don't know that. And so we're going to see, okay, how's it going? This is at 4 characters. Yeah, I don't want to do that. So if I had a faster GPU, this would be nice, but I'm just on a little laptop. So we're going to add his hash to the list. And I can set it to keep going. So it'll eventually get there.
So this is continuing. You didn't stop what you were doing before.
I
Just
did stop
continuing.
it.
Okay.
So if you can see, it's now at 1 character again.
Okay.
Now, so this is good, but unfortunately, it's going to try every single character. It's just going to try everything. So we're going to do something a little bit different. I don't want to do just a plain brute force because, well, it's not very good. That's not a good idea. So we're going to do something called masking. So let me see if I can show you. Let's see if they've got it in here. Yeah, so Hashcat has built-in character sets that we can use. And so these are the indicators for them, and then these are the characters that show in. So we've got here, like L means all lowercase characters. U is uppercase, D is digits, H is hex, capital H is hex with capital letters. Then you've got S for symbols. Then you've got A. Now A is a little weird because it includes L, it'll include U, it'll include D, it'll include S. A is like all, exactly. And then you've got B for binary, so it's going through actual binary. It's not testing this, it's testing the binary representation of 0, 0, or the binary representation of the hex value FF.
I barely just downloaded this.
Okay, so we're going to go ahead and do the exact same thing that we did attack type 3 brute force, but instead we're going to do, let's just do all lower characters. So we do question L, question L, question L, question L. So 1, 2, 3, 4, 5, S, E, V, E, N, K. So I'm going to try every password that has 5 lowercase letters in it possible. S-E-V-E-N. So we can just let that go. And so it's going to try and see what it can figure out. So I've never actually seen how long this would take. Oh, it tells us right here. So we're 8% through every possible value of lowercase letters.
Did you specify? Okay, lowercase. Do you specify how long, or does it just keep going
So,
forever?
so the reason why so what I did is I'll just write down for the recording. So I did question mark L.
So for
Yeah. So I just did like that. Wow. Can't type. So what this is going to do is I have to specify every single character. So if I want to try every password that's one character L, I have to put that in. And then it'll finish and it'll be like, okay, now I want to try every password that's 2 characters lowercase.
Are you able to mix and match between like lower, uppercase, and like symbols?
Yes. So, and let me show you that. Before we do that, if we look, it's cracked our password here. So we can see that it was able to solve Pips' crappy password. Nice job. Okay, so what we're gonna do is I'm gonna show you exactly what you're doing, and I'm gonna show you why we would care about that. So I'm gonna change your password, Pips, to some.
I've already backdoored it.
You've already backdoored it? Oh no. Did you guys break it already?
What are you talking about? It works just fine for me.
Let's see. Here we are. Okay. So I'm just going to hit edit. Hopefully, nope, my session hasn't been kicked. Good job. So sometimes I see passwords that are similar to this. We're going to do Pips, and then let's say he was born in 1994. Is that when you were born? Maybe you shouldn't tell me. I just guessed. So I see that all the time is people take a word and then they'll add like a date at the end. Especially old people like to do this. I don't know why. I've also seen like that a lot or whatever. But let's say we want to try passwords that would follow this method. So let me go ahead and update that, grab the new hash. Oh geez, who added test?
Yes, let me guess.
We'll try and crack that password at the end. That looks like fun. It's not too hard, is it?
Test?
Who made test? Is it a hard one? Should we try cracking it?
Give it that many characters, all lowercase.
It's a lot of
That's
characters.
a lot of characters.
All lowercase.
How many is that?
9.
9.
No, 8.
8. Okay.
This many.
So we're
8 all lowercase.
we're adding the new hash in. Okay, and so we're gonna do what he said. So instead of what was the password? It was Pips. So one
So
PIPS
just lowercase.
1 2 3 4. And then we want digits, right? So I'm doing LLLDD. So we'll give that a shot. Now this one's going to take a little bit longer. It shouldn't take more than a few minutes, but that's how we're trying it. So we can see that it's trying characters and then numbers. Super awesome.
Let's build a password cracking rig.
Let's build a, yeah. He says, let's build a password cracking league. Does anyone want to donate? Let's do it.
We should
So
just ask Duzzy to give us time at the
Supercomputing.
That'd be nice. He won't do it.
So the cool part about this is we've started cracking passwords and we're doing it. It's nice, it's easy, it's cool. Unfortunately, it's not good enough because we've only cracking passwords that we either know the format that it's in or are able to guess it. Side note, cool formats to use. Dates are super common. Addresses are really common, and phone numbers, things like that are first things I'd try. But once we've tried all of those, we can only get so many of the passwords. We need to start working towards something else. That's where we start getting crazy and doing dictionaries. So one of the cool things that you can do with a dictionary is you can say, instead of tacking on a word, just random letters, let's create a whole list of all the words in the English dictionary and try those. Then let's try the list of all the words of the English dictionary, tack on some numbers at the end. Or let's say somebody thinks they're smart and wants to do a capital letter, but they put it at the first. So we see that all the time, is these various passwords. Or they want to use a symbol, and so you take a dictionary word and you tack the symbol at the end, because 99% of the time that's where it is.
You
And
replace the letters with
or
symbols.
you do leet
numbers.
speak and you replace numbers. And so what we want to do with that is we want to do dictionary, and we want to do combination tags or rules. So I'm going to show you a really cool rule that I like. It's called, let's see if I remember it. I don't remember what it was called, but it was in this repo. Hang on. No, it wasn't. What was the rule? I don't remember. I'll have to find the rule kit set that I found this morning that I was playing with and I really liked. But I'll show you what rules are. So Hashcat has the ability to do rules and play with them. So the way that they work, and they're a little bit fun, is they take the dictionary that you give it, and then they'll mess it up. And so, like this rule, what it'll do is it'll try what they'll do is they'll try, say, taking one word of the dictionary and then tacking the word again at the second time. Or they'll take it and they'll try to upper character the first letter, and they'll do different things. Hashcat rules can get complicated, and we'll save that for the next class, but using them is super easy. And so, nice part is that Callie has a ton of them.
It's getting warm in here. All those GPUs.
See if my computer still works, even though it's... Okay. So what we can do is we can look at the Hashcat rules that they've got and play with them. So one of the fun ones, this is the one I like. It's the dive rule set. I like that one a lot. So we'll go ahead and try applying some rule sets to our passwords. So let me grab that. And we need a dictionary. So at the same time, does anyone have a dictionary that they like a lot?
Once they have that RockU file.
Okay, so Callie also has, wow, I just went to RockU's website. Hashcat has this rule set, and they've also got the RockU database available for download on the thing, and then these are easily downloadable. So I'll go ahead and download that. Hopefully it doesn't take too long.
Everybody start downloading shit.
Yeah, right now. We don't do any rate limiting for users yet on our Wi-Fi, so. Okay, so, oh look, it finished, and it found our password, pips.
At 13%.
Yeah. Just, it found it. I don't know why. But it was past 13%, it already found it. Okay, so let's, oh look, that says 1. I might already have it.
I feel like if the file hash matches completely, Chrome will just say it downloaded and link you to the same file.
Yeah, see, look at there it is. Rock you. Don't ask me what that is, that's weird. So RockU has a sweet database of actual leaked passwords. So that is super helpful when we're doing our attacks, because then we can use them and we can we can mess with them. So let's set up a dictionary tag. So to do a dictionary tag, it's not that much different. I'm gonna do we're gonna do a straight attack. We're gonna do give it the hash. Then I want to give it the dictionary. So mine was in the downloads folder. So now what it's going to do is literally try every single password possible in the dictionary. So we can just run through those. This one's a little faster because there's not that many. In fact, I'm kind of curious how many.
WC.
So it's only 14 million.
Only.
So believe it or not, 14 million is really easy to run through for password cracking. Not on my.
How many passwords is it? Just like all lowercase 5 characters. That's
a lot
I mean,
more
that's
than
26 to the
So the
power
way
of
to
five.
so the way to figure out how many tries you have to get to solve a password, it's just math. That's my calendar.
People like that.
We were told there was no math.
I'm sorry, there's some math. So the way that it works is you will take the number of characters possible. So if it's all lowercase, it's 26, and then you'll put that to the power of how many characters there are. So if it's a 6-character password, it's 26 to the power of 6. So maybe not programmer.
Can you do it in Bash? You can just type that right in.
I don't know.
Because I know if you're writing a Bash script, you can just do raw math like that. Or like echo that.
Okay, so that comes out to 308 million passwords. Now, if it's 7 characters, that goes into 8 billion passwords.
That's lowercase. If it's lowercase,
Yeah.
upper alpha, or like uppercase alphanumeric, which is 50, 60.
Yeah. So 8 characters is when you get in 208 billion. Now, that's surprising, but I was watching a video yesterday about a guy who had 4 Titan X's, which aren't even the fastest GPUs anymore. These are kind of older. And he was pulling 8 billion hashes per second with MD5. Like, that's pretty sweet. So, but once you start hitting 9 characters, you're like in the, what is that?
Trillion.
Million, thousand, million, billion, trillion, 5 trillion, and that's where it gets really slow. So say we've got just upper and lowercase character passwords. I mean, it doesn't even want to show what that is. You can get a little crazy. So you're 8.
That's also if you're just doing random characters. If you're going for dictionary or words, the longer the letters go, the fewer words are actually.
Exactly. And so this is brute force attacks. What he's talking about. Modern password crackers don't really do brute force attacks anymore. They will for the first few, and then they'll stop and they'll do exactly what you were mentioning, which is we'll use word lists, we'll use combinations, we'll use rules to try to follow patterns that people do and break the human, not the password. Because after about 9 or 10 characters, password is not really viable to crack. Now, at the same time, they can solve the brute forcing bit a little bit and the password by making them slower. So that's what different hash types are. All that is you've heard MD5 is broken and everyone says use bcrypt or whatever the latest one is. All the difference is how long it takes to take the plain text and turn it into the hash. And for us, that sucks because it means that our few passwords that we're trying to break take a lot longer. Wow, did it really crack? Yeah, it cracked both my passwords. Okay, so RockU, I guess, has my passwords in its database. I didn't know that, but it does. So Dumby's password is Red Hot Chili Peppers, and the admin password was Mewtwo666. See, and that's the difference between brute forcing and using dictionaries. Like, there was no way that I was going to crack Red Hot Chili Peppers with a brute force. That's not happening. But with a password we can. So does anyone have any questions so far?
Just really quick, when you did that dictionary, can I see the line that you did?
Right there.
Awesome.
So you do Hashcat, you do -A, which is the tag type, -M for the mode for which hash we have. So I chose 400 for the PHP pass because we identified it. Then our list of hashes that we're trying to crack. And then the file with my dictionary in it. Yeah.
Thank you.
Yeah, so that's all I've got for the password cracking section. I want to talk a little bit more because I've got about 5 minutes left about creating good passwords and how you guys can do that. Just because I always feel that's important as security professionals that we do that. So one of my friends, Aaron Toppins, has written a really cool, if I've said his right, Topons. I don't know. He's written a really cool tool. Yeah. To help you generate passwords, but mostly he talks about entropy. And so when you guys get a minute, I want you to go read his paper about entropy, why you would use it, what it is. But basically, the reason that we talk about entropy is that's your word list that you're picking from, how many possible passwords could end up. So, for example, with this password generator here, here's a really, let's see, let me show you my favorite one.
That Trump one.
Yeah, that's what I'm looking for. Where is it?
I think it's up in the upper left-hand corner. One up.
Yeah, so right here, he's got a generator, and what it does is he's taken every single tweet that our President Trump has done, taken all of his words and put them into a word list, and then it randomly picks one of those. And with that, he was able to generate 77 bits of entropy. Now what that means is that so when you're doing just a normal password, you could choose lowercase letters, you can choose uppercase letters, you can choose whatever. So to get 77 bits of entropy with just lowercase letters, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. You have to type a lot. Like, it takes a lot of time. And the reason why is because that's how many different possibilities that there are. So you want to keep your password within the green zone, and so that's all it comes down to. And so I like to use, these are called passphrases because they're easy to remember. I mean, even short passwords, as long as they have enough in their character set, are viable. See, this password here is 11 characters. It's pretty small compared to the rest of them, but it is just as secure as any of these other ones because it has lowercase symbols, because of the available things that it can choose from. Anyways, so that's all I've got. Does anyone have any questions?